Students, this is a very important topic, LCR circuit. We consider an AC circuit in which a resistance R, inductor coil of inductance L, and a capacitor of capacitance C are connected in series across a source of alternating EMF E is equal to E naught sin omega t. Current in the circuit is I. Since all the elements are in series, current through each element will remain same. VR equal to IR. Voltage drop across resistance is in phase with current and it is denoted by OA in the phasor diagram. VL is equal to IXL is the voltage drop across inductor coil which leads current in phase by pi by 2 and denoted by OB in the phasor diagram. OC represents VC, that is equal to IXC, which lags behind the current in phase by pi by 2. So VR is in phase with current, VL leads the current in phase by pi by 2 and VC lags behind the current in phase by pi by 2. VL and VC are oppositely directed. We consider VL is greater than VC. In the diagram, OD equals to VL minus VC. So now from the phasor diagram, effective voltage is denoted by OP, that is OP square is equal to OA square plus AP square. Substitute the value of OA and AP and solve. You will find E square is equal to I square into R square plus XL minus XC square, or E square upon I square is equal to R square plus XL minus XC square, or E upon I is equal to root R square plus XL minus XC square root. Students, E upon I has same dimension as that of resistance. It is called impedance of LCR circuit. So Z is equal to root R square plus omega L minus 1 upon omega C square. From the phasor diagram, you can also see tan phi is equal to AP upon OA. That is, tan phi is equal to VL minus VC upon R, or you can say omega L minus 1 upon omega C upon R. Here phi is the phase angle by which voltage leads current in phase. Now we consider the case if VC is greater than VL. Students, if VC is greater than VL, the resultant of VL and VC will be the downward, that is OD, now equal to VC minus VL. In this case, impedance is given by Z dash is equal to root R square plus 1 upon omega C minus omega L square, and tan phi is equal to 1 upon omega C minus omega L upon R. So remember students, whether VL is greater than VC or VC is greater than VL, in both the cases impedance remains same. Z or Z dash both are equal. Only the difference is that if VL is greater than VC, then voltage leads the current in phase by angle phi, and if VC is greater than VL, VC is greater than VL, then voltage lags behind the current in phase by angle phi.